Today's lesson is a continuation of what you learned yesterday about inverse variation. So if you have not done yesterday's lesson and watched the two Khan Academy videos related to direct and inverse variation, please do that first. So picking up where that left off, our goal today is to write and graph an inverse variation equation. So yesterday you did a couple graphs of direct variation, which is basically just a graph of a linear equation. So that should have been super easy, and you should have said, we've done this before. So yes, you have. So now we're looking at the inverse variation part of it. If we want to write and graph an equation, we're going to start with an example. So if I told you that y varied inversely with x, and I told you that one of the points that makes that equation true, or one of the points that lies on that graph, is that x equals 2 and y equals 5, and I asked you to write and graph an equation to show that relationship. So the first thing that we would do is to find the value of k, keeping in mind that an inverse variation is y equals k over x. So if I know y and I know x, then I need to find the value of k. So I'm just going to plug in one of the points that I know, which is, again, 2, 5. So I'm going to plug in the 2 for the x and the 5 for the y, and I get k equal to, I'm sorry, I'm going to multiply both sides by 2. So I have 5 times 2 equals k, and k equals 10. So once I find the value of k, then I can write the equation. So my equation is going to be y equals 10 over x. I go back to x and y because 2 and 5 was just one point in that relationship, one point that made that equation true, one point on that graph, but it doesn't represent all of the points on that graph. So I want to go back to having my y and my x, and now I know that k equals 10. So pretty straightforward to write that equation. The next thing that we want to do in terms of graphing it is we can start with making a table of values. I know already that 2 and 5 is a point that makes that equation true. I want to consider always, we almost always start with 0, right? So keep in mind, if my equation is y equals 10 over x, if I put a 0 right here, I basically have a division problem where I have a number divided by 0. And we know that that's not possible. So just going back to the basic idea of division, I can't take something and divide it into 0 groups. That's why when you try to do that on your calculator, it tells you that it's undefined. And if you ask Siri a question where you ask it to divide by 0, she gives you a long, drawn-out, crazy answer. If you've never tried that, pause this video for a minute and ask Siri, what happens when you divide by 0? So I know that this value is not possible, and so we're going to call that an excluded value. It cannot be part of our graph because it can't be a point on that graph. So that's going to become more and more important as we move into graphing more complicated functions of this type. If I put x equals 1, then y is going to equal 10. If I put x equals 5, y is going to equal 2. And notice that I'm picking numbers that are going to give me whole values. I could also include some negative numbers. So say, for example, I included -5. I'm going to get -2. And if I include, I'm going to put a few more points over here. If I included -10, I'm going to get -1. So I do want to have both positive and negative values. So the next step is going to, step 4, I'm noticing the excluded values, again keeping in mind that the denominator of a fraction cannot be 0. So the next step in graphing is going to be to plot the points and draw a smooth curve. So I'm going to use the points from my table. So I just plotted all of the points that we had included in our table, and I'm starting to see the beginning of a shape, but I'm actually going to add a couple more points to my table so that I get this full shape. So again, I've got the x and the y. My equation is y equals 10 over x. So I can see what's happening here, but I want to go out here a little bit further. So I'm also going to put in my table, what if x is 10, then y is going to equal 1. So that point is going to be right here. And so you'll notice that I now have this curve. It can never cross 0 because that's the excluded value. X can never be 0, and y is never going to be 0 either, because not 10 divided by, there's no possibility for x that's going to give me 0 for y. So I know that I'm never going to cross the y-axis, I'm never going to cross the x-axis. So my graph really looks like this, with this being an asymptote. We've seen that before. And so we've got an asymptote right here, meaning that it gets closer and closer to x equals 0, to y equals 0, but never touches it. We also have an asymptote up here, where it's getting closer and closer to x equals 0, but never really touching it. So it's really going more like that. You'll also notice that I have a mirror image over here. So I've got a couple points. Let's do a point right in here. So what if I have like -2? 10 divided by -2 is going to give me -5. So I've got 1, 2, 3, 4, 5. And then let's do -1. And that's going to give me -10. So I'm going to be down here somewhere. So again, I'm going to have an asymptote right here, getting closer and closer to that axis, and I'm going to have an asymptote down here. So my graph is going to look like this, where I have this curve and the reflection of it across the origin on this side. So this graph is an example of a graph of an inverse function. It's also an example of a rational function. So inverse functions are basic rational functions. Our graphs in this unit are going to look a lot like this. This is going to be the basic shape, just like with linear equations, our basic shape was a straight line. With quadratic equations, our basic shape was a parabola. Square root functions, our basic shape was the kind of the sideways parabola, but just part of it. So on a rational function, our basic shape is going to be going to look like this. And for a rational function, y equals 1 over x is the parent function of our rational function. So today you're going to practice on Clever tonight, just doing a couple basic graphs related to inverse functions, and then we'll pick up the next day with more complicated rational functions. But just an introduction to that, a rational function, an inverse function is a rational function, and it's in the form of y equals some polynomial, in this case just 1, divided by some polynomial, in this case just x, where the denominator does not equal 0. So my denominator cannot equal 0. That becomes my excluded value, and it becomes where my asymptotes are on my graph. So again, tonight is just writing some of these inverse equations and then doing some basic graphs, and then we'll do a lot more with the graphing of them the next day. So this is what you should know today, and then how you should show that you know it is doing a Clever assignment, which is pretty short tonight. So see you tomorrow.